Hello and welcome. So we are going to solve an interesting question under geometry. The question says we should find the area of the red shaded region. As you can see, we have three cycles. We have one, two, three. You can see they collide, and this is the region that they want us to find. All right. So if you look at this object, you are going to see that from this point to this point is 2, and from this point to this point is called a radius. And then we're having the radius of each cycle. So it means we have the same cycle, and they are having the same what? The same radius. So for us to solve this question, the first thing we are going to do is we are going to join these 3 points together. So let's join these 3 points together and let's see what we are going to have. All right. All right. So we join this part with this part. We join this part with this part. All right. So we have triangle A, B, and C. All right. So let's bring out this triangle. So if we decide to bring out this triangle, we are going to have our triangle in this form. Right. All right. So here we are going to have this. Right. All right. So here we have here to be our A, here to be our B, and here to be our C. All right. Now, to take note of this, we said from this point to this point is radius. From this point to this point is another radius. From this point to this point is radius. From this point to this point is radius. From this point to this point is radius. And don't forget, we said the radius of this cycle, each of this cycle is 2. So it means from here to here is also going to be 2. From this point to this point is going to be 2. From this point to this point is going to be 2 units. From this point to this point is another 2 units. From this point to this point is another 2 units, then 2 units. So now it means AB, length AB is going to be 2 plus 2, that is 4. So this place is going to be 4, this place is going to be 4, and this place is going to be 4. And this forms an equilateral triangle. All right. So now that we've established that the triangle here is an equilateral triangle, we know that the angle that is sustained by an equilateral triangle is nothing but what? 60 degrees. Sorry, we are going to have 60 degrees here. We're going to have another 60 degrees here. And we're going to have another 60 degrees here. All right. So we can, therefore, if we extend this part to this part, for us to get the height, we can extend this down. So it means that from this point to this point is going to be 2. From this point to this point is also going to be 2. So this is the height, right? All right. So it means here is going to be a right angle. Here is another right angle. All right. So for us to get the height, all right, we are going to apply Pythagoras theorem, because the Pythagoras theorem states that the hypotenuse side is the sum of the two other sides, provided that they are what? They are all square. And this is the hypotenuse side. You can decide to use any part of the triangle so to get the height. So it means that 4 square is equals to 2 square plus what? Plus h square. All right. So if we make h square the subject here, h square will be equals to 4 square minus 2 square. 4 square is 16 and 2 square is 4. So 16 minus 4, that is 12. So it shows that h square will be equals to what? It's going to be equals to 12. All right. So for us to get the value of h, we are going to square both sides. If we square both sides, it means that h will be equals to the square root of 12. And the square root of 12, we know we can express 12 as 4 multiplied by what? By 3. So by breaking down the square root, we are going to have root 4 multiplied by root 3. So h will be equals to root 4 is 2. So we are going to have 2 root 3. All right. So the next thing we are going to do is we are going to find the area of this equilateral triangle. So the area of this equilateral triangle, area will be equals to half base times what? Times height. So if we substitute this now, our half is going to be half multiplied by our base. The base is 4. So we are going to have 4 multiplied by height. The height is 2 root 3. So this will be equals to 2 here 1, 2 here is 2. 2 times 2, that is 4 root 3. So the area of this equilateral triangle is nothing but what? It's nothing but 4. All right. Now, don't forget, we want to find the area of this red portion. That is what we want to find. All right. For us to find this area, we connect the point, all the point together to get the area, to get the triangle inside. So if we subtract the area of this triangle now from what we have, if you look at this point now, from this point to this point, if I decide to clean this part of the cycle, then what are you going to have? This is a radius and a arc. Again, you will see 2 radius and a arc. This is another 2 radius and a arc. So it shows that we have a sector. Is that clear? So we have how many sectors? 3 sectors. 1, 2, and 3. Is that clear? So if I subtract the area of this equilateral triangle from the area of this 3 sectors, I am going to have the area of the shaded portion. All right. So now, the next thing we are going to do is to calculate the area of one side of the sector of the cycle. So sector now, area of a sector. All right, the area of a sector. We still recall the formula for the area of a sector. That is theta all over what? 360 times what? Times pi r square, right? All right. So now we know that the angle sustained here is 60. The angle sustained here is 60. The angle sustained here and here is what? 60. So it shows that our theta is going to be what? 60. 60 all over 360 multiplied by pi times what? Times radius. And the radius of each of the cycle is just what? Is 2. So we are going to take this one to be what? 2 square. All right. So now this will be equals to 0 here we cancel out 0. 6 here 1. 6 here is 6. Right. So here we are going to have 4 pi all over what? All over 6. Again, we can reduce this by 2. 2 here is 2. 2 here is 3. So we are going to have 2 pi all over what? All over 3. All right. So this is the area of a sector. So this is just the area of a sector. Now, for us to, we have 3 sectors here. 1, 2, and 3. Because the cycle is the same. It means the area of the sector 2 will be the same. So it means we have 3 sectors. 1, 2, 3. So for us to get the area of the total sector now, we are going to multiply by 3. Is that clear? So the area of the total sector now is going to be equals to 3 multiplied by 2 pi all over what? All over 3. So 3 will go with 3. Then the area of the total sector will be equals to just 2 pi. All right. So now the area of the red shaded region now. Area of the red region is equals to area of an equilateral triangle minus the sector. I don't know. I want to arrange this. Okay, let me just write it here. Area of the total sector. All right. So this will be equals to the area of an equilateral triangle ABC is nothing but what? 4 pi. 4. I say 4 pi. That is 4 root 3. 4 root 3 minus then 2 pi. We have 2 pi. So here is our answer, or we can further factor out 2 here. So 2 into here will be left with 2 root 3, then minus what? Minus pi. So the unit of this is going to be what? Unit square, because I can see we just have 2. We don't put it in meter or centimeter, so it's going to be what? Unit. So this one is going to be unit square. All right. Similarly with this, unit square, and similarly with this, unit square. So there is how to go about this question. So stay tuned as we are going to be solving more numericals on geometry. Thanks.